Repairing a 2-inch scale Fowler traction engine part 2, tackling the flywheel problem by making and fitting a new key. The way that this flywheel is fitted to the crankshaft is a disgrace. Apart from having a key that shows signs of serious ultraviolence, there's also a parallel piece of bar that goes through a taper hole. I think once I've removed the old key and made a new one, I'm going to also fit a taper pin, a proper one. This clip was first shown in the first episode, and you can see how much the flywheel moves on the crankshaft. And it's the flywheel that stops the crankshaft from moving from side to side. In my opinion, this is the first problem that I need to address. I'm using a needle file not to clean up the key, I'm using it to file a groove in the key so I can tap it out using the point of a screwdriver. That's the plan anyway. It took a while with this very small needle file to file a groove in the key. And now I have to be really careful. I'm using the point, first of all, of a very small screwdriver, which was a bit small and kept falling out of the slot. So I used a larger screwdriver, and this started to move the key eventually, but the key was really tight, but only in the flywheel, not against the crankshaft. This clip is at twice normal speed, and you can see the hammer blows are all light, just plenty of them. Eventually the key starts to move, but it's still very tight in the flywheel. There is evidence of epoxy resin around the edge of the flywheel boss, and I think the key's been glued in with this stuff as well. Once the key was out, I scraped the front of the flywheel, then I used a wire brush to remove most of the epoxy resin because I don't want this. Looking at the build quality and the paint job on this traction engine, which is pretty good, I'm fairly certain that the fitting of this flywheel to the crankshaft so badly was not done by the man who originally built the engine. At first I thought the cross pin was a taper pin, but it wasn't. It was just a parallel piece of steel tapped in there. Thankfully now the pin has gone forever. I thought I might like to show you the key. You can see the bit that I filed on the end of it, but look at the state of it, it really is rough. This key is utterly wrong, so I'm going to make a new one. I took some rough measurements of the existing key, even though it's now bent, and it is 3/16 square, or that's what it's supposed to be. I'm going to make a new key out of a piece of square bar, starting by squaring up the end of it. For no particular reason, I just like to start off by squaring up the end. If I turn something in the lathe, I will face the end of the work first. To make this cutting job easier, I sprayed some metal cutting spray on the work. It's good stuff this, it smokes a bit, but you can really feel the difference between a dry cutter and one running through this mess of oil. As you can see in this clip, the direction of rotation of the cutter is correct. Always use the cutter facing towards the work, never away from it. And if you're taking a thin piece of metal off, just use the centre of the cutter. This job would probably have been easier if I'd have had a piece of steel that was 3/16 of an inch thick, but actually I had a good look in my bits and pieces box and I didn't have any. I need this piece of steel to end up slightly more than 3/16 of an inch in diameter, because the final sizing I will do, believe it or not, on the belt sander. I will get a ground finish and it will be very smooth. As it turns out, by checking with the micrometer, it's nowhere near 3/16 just yet, so it's time for another cut. I've omitted the lubricant so you can see a clearer image of the cutting process. After this pass, the thickness of the piece of steel is just slightly above 3/16 of an inch. The next part of the job involves taking the piece of bar out of the machine vise, turning it over and starting again. This time though, I'm not milling all the way down because I need to leave a piece of this key stuck up so I can lever it out once it's in the keyway. Once I'd finished this part of the job, I didn't cut the key off the end of the piece of bar. First of all, I tried it for size, and when finally the key was a good fit in the slot, I cut it away from the main piece of metal. There is of course a problem. The key is sticking out too far. I thought this might happen, so removed the key, shortened the end of it and tapped it into position fully. This key is not Loctited in position, it's just a nice tight fit. There's something wrong with this, I will address that shortly in the video. For now though, I'm going to run the engine to see whether tightening up the flywheel on the crankshaft and the crankshaft itself, which doesn't move from side to side, makes any difference to the sound, and indeed it does. I can't believe the lack of ability with some people. This is a taper hole, and this was the pin that I removed, and it was just smashed with a hammer in an attempt to get it to fit. Over now to my trusty Myford ML7, and I'm using a piece of wood to clean up the inside edge of the cover. To be honest though, it worked much better when I wrapped the piece of wood in a piece of wet-to-dry sandpaper. This clip is just to illustrate the procedure. This clip shows the end of the crankshaft with the proper taper pin fitted. When I run the engine, it is definitely quieter than it was originally. As I repair the rest of the motion work, with a bit of luck, the entire engine should run much quieter than it is at the moment. The knocking is not quite as bad as it was, but it's a long way to go just yet. I wanted to clean up the mess around the boss of the flywheel, so I did this by holding a piece of emery cloth against the paint. And here is the first coat of Phoenix Precision Paint's gloss black that I'm going to apply to the flywheel boss. I'm also touching in other areas of the flywheel around the spokes. Unfortunately, doing this does not make the traction engine run any quieter. There's a bit of a problem with the cap that fits on the end of the flywheel. Whoever bored it originally didn't bore it all the way down, and there is a ridge that actually catches on the key. So here I'm machining it away, and now the ridge has disappeared forever. When I try the cap in position, it's a lot better fit. It certainly doesn't need all the epoxy resin around the outer edge. I may fit a gasket though, just for appearance's sake. And that is about it for this episode. To finish, I'm going to run the engine in slow motion, and you can hear clearly that it's still knocking. But as this is running at 25% normal speed, the knocking occurs 25% slower. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.